Hello and welcome, everyone. Thank you for joining us today for our webinar on the hidden costs of AI and how storage can save you. In today's session, we will discuss how to successfully build a cost-effective and efficient AI infrastructure, accelerating innovation and results. Our expert today is Franklin Velasquez. Franklin is a senior technical marketing specialist at Cobite. He combines his passion for power electronics, control systems, and AI with a solid background in electrical engineering. Driven by the desire to change the world through technology, he applies his expertise to innovate and communicate complex technical ideas effectively, making technology accessible and impactful. With that, I'll now pass it over to Franklin.
Thank you, SK. Welcome everyone to this webinar. I'm really happy to be here. So let's dive right into it. And I want to say that the true cost of AI is often hidden from project stakeholders. This usually leads to budget overruns and project delays. And while AI projects promise great rewards, it's important to know the potential costs involved before starting one. So in today's webinar, we'll explore the costs associated with AI that people tend to forget when starting an AI project. We will cover factors contributing to AI costs, such as the type of AI. We will look at some of the challenges that drive the cost of AI projects, but we'll mainly focus on generative AI or Gen AI. We'll also look at the costs that people might overlook before starting a project and see some of the stats on AI cost. Next, we will look at the data storage requirements for AI projects. And lastly, we will just see how Cobite it's a unique storage solution that can help you reduce your AI storage cost. So as AI cost continues to rise, companies must carefully analyze their AI projects before starting them, because it's important to balance the expected benefits and costs to ensure that projects makes financial sense. Overlooking the hidden costs of AI can cause budget issues and delays, and this puts the project success at risk. So let's take a look at some of the factors that contribute to AI cost. And one of them is the type of AI use cases. The first one that I want to talk about is chatbots and virtual assistants. These technologies simulate human conversation to assist users in completing tasks, accessing information, and solving problems. These tools can range from simple systems that respond to specific commands to more advanced AI-powered assistants capable of understanding and generating natural language responses. These projects rely on various types of AI to function properly, and this include natural language processing or NLP. The more advanced chatbots use NLP to parse and understand human language, allowing them to respond to a wider range of queries and engage in more natural conversations. NLP involves syntax analysis, entity recognition, sentiment analysis, and much more. Next, we also have machine learning algorithms, and these help chatbots learn from data, adapt to new situations, and improve their responses. The third, we have deep learning, which is a subset of machine learning, but deep learning uses neural networks with many layers to process the data in complex ways. And fourth, it's a speech recognition. Speech recognition technology is crucial for voice-based virtual assistants like Siri, Alexa, or Google Assistant, among others, because it converts a spoken language into text that AI can process. And chatbots and virtual assistants are a powerful tool for automating interactions and providing user support. And the AI technologies behind them enables them and enable advanced functionalities, but also require significant investment in development, integration, and ongoing management. Even though these are said to be some of the low complexity AI use cases, they tend to they can be very complex and costly at the same time. Next, we have image recognition, and this involves AI systems identifying objects, places, people, writing, and actions in different images. This technology enables computers to process and interpret the visual world like humans do, but at greater speeds and potentially with fewer errors, depending on the application. And these rely on different AIs as well as the first um, use case that I just spoke about. One of them is deep learning. In image recognition, deep learning algorithms ingest thousands to millions of labeled images to learn various features and objects. The performance of these systems often improves with the amount and quality of the training data. Next, you have neural networks or convolutional neural networks or CNNs. These are designed to mimic human brain functionality and enables the machines to recognize patterns and features in images. CNNs use layers of neurons to filter and learn from image data, and this trains the system to recognize distinct characteristics like edges, shapes, and textures. And the third, we have transfer learning. Because often training a deep learning model from scratch is resource intensive and very costly. So transfer learning involves taking a pre-trained model and fine-tuning it for a specific task. This approach is faster and less resource heavy, making advanced image recognition accessible to more users and applications. And image recognition is widely used in security, retail, and healthcare. For example, in the healthcare area, there's Siemens Healthineers. You might have heard of them, but they use image recognition in different areas, from enhancing the quality and efficiency of medical imaging to aiding in diagnostic and treatment planning. The third use case is autonomous vehicles, and these are AI systems that enable self-driving cars using sensor data for navigation and decision making. Autonomous vehicles heavily rely on artificial intelligence to interpret their surroundings, make decisions, and navigate safely without human intervention. Um, and they depend on, again, also a wide range of AI technologies, which include machine learning and deep learning. These technologies enable uh, autonomous vehicles to make sense of complex scenarios and learn from large amounts of driving data. Deep learning in particular helps in making predictive decisions, such as anticipating the actions of other drivers or pedestrians. And then more specific, we have deep neural networks. These are used for tasks such as object detection, classification, trajectory prediction, and more, right? These deep neural networks can learn to perform this task by training on large data sets of driving scenarios. Um, and that's why you see all these cars um, with all these sensors and cameras trying to take all this data. But then you also have reinforcement learning. This type of machine learning is used for developing decision-making algorithms. It involves training models on scenarios where certain actions lead to rewards or penalties. And this mimics the learning process of a human driver. And the third one, or the last one that I want to mention here, is NLP. Again, this allows the vehicles to understand and respond to voice commands and interact with passengers in a more human-like manner. Um, the AI technologies using autonomous vehicles need to continue evolving, specifically with a rich research focus on improving the robustness, efficiency, and safety of these systems. And one use case that I just want to mention is our robot taxis. For example, Sooks, you might have seen it um, if in the news, or if you live in the Bay Area, you might have seen them somewhere. But these uh, autonomous self-driving taxis, they don't have a steering wheel or pedals. They are fully automated, and they are very nice. But the next one that I want to talk about, it's content generation, or Gen AI. This encompasses technologies that generate new content, whether it be text, images, audio or video based on patterns and information learned from large data sets. And this branch of AI is particularly notable for its ability to produce outputs that mimic human-like creativity in various applications, such as art creation, music composition, or content writing. And Gen AI relies on deep learning a lot. And two of the prominent examples of AI use on this include generative adversarial networks, or GANs. This consists of two networks, neural networks, the generator and the discriminator, which compete against each other. The generator creates content, and the discriminator evaluates it against the training data. And this process continues until the discriminator can no longer distinguish the generated content from real data. Um, and then you also have transformers. These were originally designed for NLP tasks, but transformers are now used in Gen AI for their ability to handle sequences of data. They're particularly effective in understanding context, which is crucial for tasks like writing coherent paragraphs or generating music with a consistent theme. And with that, I want to dive into some of the challenges that drive costs for Gen AI. One of them, and I think one of the most important one, is the data concerns, because these models need, or any AI project needs very large amounts of data and good quality data. And for Gen AI especially, you need relevant and varied data, right? Because if someone asks the project to write something like a news or something about the news, it needs to have relevant data, because it won't serve any purpose to give all information. But then you also have copyrights issue, because you have to check the data that you're going to use. You can't just use random data. If you use someone else's data, and if it is copyrighted, you're infringing those copyrights. And court proceedings can happen, and they can be very expensive and become a big problem. Um, then we also have computational resources. Training Gen AI models, especially those based on complex neural networks like GANs or LLMs, they demand significant computational power. And this usually means using specialized hardware such as GPUs, which are expensive to acquire and operate. Then we also have model complexity. Um, Gen AI models are very complex and require careful tuning and optimizing to produce high quality results. Developing these models involves extensive experimentation with different architectures and parameters, which can be lengthy and costly. And lastly, we have talent and expertise. The field of Gen AI is highly specialized and requires expertise in machine learning, data science, and even domain-specific knowledge, depending on the application, such as linguistic for text generation or art for image generation. So skilled professionals in this area are in high demand, and they usually command high salaries, and this contributes to the overall cost of projects. Some of the general challenges that also apply to Gen AI um, include the amount, quality, type, and labeling of data. Um, but the more data you have, the better your AI can learn and improve. But you also need to pay attention to the quality of the data, because that's important. If you have bad data, that can lead to inaccurate results, which can be very costly as well. And the type of data that you have is also important. Some types of data, such as images, videos, are more difficult to process than others, such as text. And then also labeling data. Sometimes companies will have to pay for the labeling and all that. And one of the major challenges that there is for AI projects and costs is that there is no generic AI. Yes, you have pre-trained models or large language models, but you need to train them specifically for one task. Yeah, as I said, you can use a pre-trained model and then train it for a specific task. and then optimize it, and lastly, write an application that uses it. But models are not general components for different tasks. You'll most likely need to optimize the pre-trained models for your specific application. And this means that you will need to do more training anytime that you want to use your model with different tasks. Um, and these are just typical things to consider, or that everyone needs to consider. And there are also some others, such as GPUs being hard to get, and they are very expensive. Also, the staff, as I was saying, it is hard to find good data scientists, and you have to pay them lots of money. You sometimes need to ask yourself if you have the computing power to bring and attract good staff to your project. You will have to see if they want to come, because if you don't have the right staff, your GPUs might be idle, and that will be a big problem and a major cost for you. So some of the hidden costs that I want to go into, or mention, um, are the following. The first one is training a model. This usually includes cost of data collection, data preparation, and any other costs associated with training a model. People usually underestimate the cost of training. There are applications of deep learning, transformers, and all kinds of neural networks to specific problems. And even if you have general models like LLMs, you still need to train them for your specific task. Um, they are not like humans. Humans can apply existing knowledge to new problems, but machine learning models, they can't. They only repeat what they have seen, and they can invent new stuff. That's why you need to continue training the models. Um, and this goes in hand with maintenance and supervision. Fixing the mistakes that machine learning models make is part of maintenance. You've probably seen Google's AI response to the question, "How many rocks should I eat?" If you haven't, the AI response was that, according to UC Berkeley geologists, you should eat at least one small rock per day, because that was good for your system. But in this case, the AI couldn't really identify like sarcasm, right? Um, but I think they already fixed this. But all these are part of maintenance and supervision. For example, for chatbots, you need to make sure that it's not saying inappropriate stuff. Um, and overall, after training and deploying your models, you can just leave them in the wall. They need supervision. The next one is data center cost or energy cost. The data center cost of AI refers to the cost of building or renting the data center that will be used for the AI project or that will host the project. And this includes the cost of power, cooling, and any other costs associated with the operation of the data center. A lot of the time when you have more than one GPU, you will need like special data centers. And these, because of the components or the resources that you have there, they use a lot of power and use a lot of energy. And you will need to have like very like advanced cooling systems. So these are things that are usually overlooked. But another one, a big one, I will say, is a storage cost. Not knowing the type of storage you need can be a challenge. In a scale-out environment, you don't really need the fastest. Buying the wrong kind of storage can drive the cost up. For example, if you purchase enterprise storage versus a scale-out storage, or using a storage that is not a good fit, or even using a storage or buying a storage that doesn't have enough capacity for your data set. Um, as I said, you don't need the fastest storage because in a scale-out world, fast is relative. But what you need is a highly available storage because your resources are very expensive. And idle GPUs and idle data scientists can cost you so much money per hour. Um, and the last one that I want to mention is cloud cost. The cloud is great to get started when you need flexibility. But if you have a high baseline usage and a lot of data, then the cloud gets very expensive. And for a lot of projects, uh, this is the difference between like being successful or maybe failing or having to back up from that project. So I just want to share a few stats with you. Um, so the cost of AI will usually depend a lot on the complexity of the project. For example, if you have like a low-level project, you will see costs from about 15,000 to 35,000. Medium level will be something around 40,000 to 60,000, or high level complex AI could be something around 80,000 to 100,000. And the last one is training your own LLM with 100 billion parameters. That will be about $8.5 million. So it can be very expensive. Next one, you also need to consider hardware costs. For example, GPUs for an NVIDIA A100, you can pay around like $10,000, or if you're renting it, it can be like um, $1.14 on Google, or like $3.06 per hour on AWS. And you also have other hardware such as FPGAs, and these are suitable for applications, and they are less expensive. They tend to be less expensive than GPUs, but they are very challenging to program, and they can range from $5 to 100,000, depending on the capability that you need. Um, and then you also have the computation or the compute instances. If you were to have a rent an instance, or get an instance from any of these cloud providers um, for a month, and with an average of 730 hours, you will be seeing prices ranging from like 23,000 all the way to almost 30,000. And these are just listed prices. They don't include any discounts. But GPUs are only part of the price, right? You also have the rest around infrastructure and the power and cooling, as I was mentioning before. Um, and having your AI project in the cloud is usually more expensive than on-prem. But you also can consider like, do you want to buy or do you want to rent? And you also have to consider the flexibility versus the ownership. These are just things that you might need to consider when starting an AI project. So to get the advantage of your talent and your resources, you need data, and lots of data, and it needs to be accessible all the time. You can have idle GPUs just waiting for the data to come in, because that's a waste of money. That's why you need a storage system capable of storing and efficiently handling all your data, so that you keep your resources busy at all the time. So let's explore some of the data storage needs that the AI projects require. The first one that I want to mention is a scale out. A scale out is important in machine learning because you need to train in a distributed manner. You can't fit everything into one GPU. You need to do distributed training for the performance. And performance is relative in the scale out because you can always grow your storage system to deliver more performance. But also scale out in capacity. You need to be able to have a large capacity because your data set needs to fit there. You must train your model on your entire data set. You can just train it on a small subset. So you need high performance and large scale storage. Next one, you also need high bandwidth. This is a throughput game. There is no low latency. The GPUs are too fast for everything. Everything on the network is too slow for them. It doesn't matter how fast your network file system is, it's always going to be too slow. So you do need to do prefetching. Um, so it's all about the bandwidth, right? Having the data coming in so your GPUs keep busy all the time. Next, you need high available storage because you want to avoid outages. Downtime is expensive, and as I said, you don't need to look for a race car that is always falling apart. You actually need a storage that is fast and reliable. Um, and the fourth requirement will be easy to run at scale. AI projects often require storage solutions that are easy to run at scale due to their unique demands of the AI workflows. And this include managing large volumes of data, ensuring high performance and maintaining flexibility as the project evolves. Because with AI projects, you will always have more data. And by understanding the storage requirements for AI projects, you can select the appropriate storage solution to support your AI initiative. And this help ensures that AI projects are successful and deliver the expected benefits. So I just want to end with saying how Kobai is a unique solution for AI. Um, Kobai is a scale-out distributed power file system and is designed to enhance AI projects by providing high-performance storage. Due to its scale-out nature, you can deliver arbitrary performance just by adding more hardware. Again, or the same with capacity, you can always increase your capacity just by adding more resources. Kobai runs on commodity hardware, so you don't need to buy expensive appliances, right? Sometimes replacing these appliances can be very expensive and very difficult at times, or all the time, I should say. Kobai also runs on flash and hard drives, so you can have very large data sets and very highly economical with high performance. Um, Kobai also offers high availability. With Kobai, you don't have disruptions. You can quickly adapt to your workload demands by adding or removing servers from your cluster without any downtime. You can also perform updates and move data without any maintenance windows. Kobai is also very easy to manage. It was designed with simplicity in mind, and with highly automated data policies, it makes it easy to run large storage infrastructures with small teams. Um, some of the policy-based data management includes you can choose how you want to um, save your files for client, file, tenant, and so on. And lastly, the last thing I do want to mention is that Kobai offers a fast file metadata query engine, and this is very useful when you have billions of files. The file query engine allows you to quickly find the right files, including the external attributes for custom metadata for labeling. So you don't need extra metadata tools or extra databases. And so I just want to leave you with this, that you can get a live demo from us. You can just contact us, and you can also get a free edition. We offer 150 terabytes for free all the time. You can scan the QR code, and yeah, it will take you to our landing page. So yeah. So if you have any questions, comments, please let us know.
Thank you, Franklin. I think we're at the top of the hour, so we would just end it here. Once again, thank you for taking the time today and doing a wonderful presentation. I'd like to say thank you to everyone who joined us today. The recording will be sent in an email shortly. Have a great rest of your day, everybody. Thank you.